Okay, this is the video lesson for 8.7c. Your job today is to use the Pythagorean theorem and its converse, or the opposite, basically working backwards, to solve problems. So we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, and we could also work backwards. So let's say that I'm looking for A, but I know B and C, then I could work backwards and find A. So that's what they mean by the converse. Go ahead and make sure that you have your full name, put today's date as the due date. And then for the stamps, let's see, 1, 2, you need 8 stamps today. And notice on number 29 it has 2 parts, so you're going to need 2 stamps on that one. So 8 total stamps. All right, let's look at number 3 together. Zoom in here, make it as big as I can. Okay, that looks good. Okay, it says Kurt and Kim went to swim at the town swimming pool. The diagram below shows the dimensions of the rectangular swimming pool. If Kim wants to swim diagonally across the pool from one corner to the opposite corner, what is the distance he will swim? Okay, I think they probably meant she, but we're going to swim diagonally from one corner to the other. Now, it may be really hard for you to see these numbers, so if it is, go ahead and write in, this is 30 feet, and this should say 40 feet. Now, if we want to make a triangle, this is going to be our hypotenuse. Okay, that's across from the right angle. This will be 30, because 30, it's a rectangle, and then this is 40. So we've turned this into a triangle. So anytime you have a Pythagorean theorem problem, go ahead and draw your triangle, because it may look like something different. Like here we were given a rectangle, and it didn't even look like a triangle, but now that we've kind of modified our picture, we can see what we're looking at. So we're going to start with, hold on just a second, Anka, off the couch. Sorry, my dog is digging in the couch. Okay, so we're going to go a squared plus b squared equals c squared. So follow along with me, please. And we did this a little bit yesterday. I walked you through a problem, and we're just going to solve just like we did yesterday. So we're going to plug in 40 for A, or you could use 30. It really doesn't matter. So 40 is our A, and then we square it, plus 30 for B, and then we square that, equals C squared. And we don't know what C is, but that's what we're looking for. Now, if you use your calculator, 40 squared is 1,600, 30 squared is 900, and when we add those together, we're going to get C squared. Okay, so then 1,600 plus 900, well, I know 16 plus 9 is 25, so 2,500 is c squared, but just like we talked about yesterday, I don't want to know c squared, I want to know c by itself. And so the opposite of adding is subtracting, the opposite of multiplying is dividing, and the opposite of squaring a number is taking the square root. So we're going to take the square root of both sides. That's going to allow us to cancel out that squared sign, so that now all we have is c. And then we end up with c equals the square root of 2,500, you would put that in your calculator, square root of 2,500, and you'll find out that that is 50. So 50 feet is our answer. And then when we put it over here, if we come over here and say C equals 50, that is reasonable. It does make sense because it's the longest side, and it has to be the longest side. If we had ended up with like 35 or something like that, then we would know that it's not a reasonable hypotenuse. So now I'd like for you to look at number 23. This is pretty much the same problem. You're given 12 feet and 16 feet, and you're looking for the hypotenuse. So please show all of your work. When you're finished, bring your paper to me for a stamp, and then we'll move on to number 4. And obviously I'm at home and I have not put a whole lot of effort into my professional appearance today, but I did want to introduce you to someone. This is baby Emmy. She's the one surviving puppy. Oh, big yawn. She just opened her eyes a couple days ago. She's 2.5 weeks old. She likes to eat a lot, and she's very fat. You see, she's got a very fat tummy. And she pretty much just eats and sleeps and poops. Now she's talking. Yep, I heard her growl a little bit ago. But I'm just holding her while I'm working. So if you hear any tiny little growls, then it's probably her from my lap. Number 4. If the 3 squares come together to form a right triangle, as indicated in the drawing, what is the area of x? The area of x. So that means I'm not looking just for this side, I'm actually looking for the whole area. And it may be kind of hard to see, that is a right angle symbol right there. And then this is x. So if it didn't print very well, there it is. Okay. So we need to kind of visualize our right triangle here. We have a right triangle. We'll call this side A. And we'll call this side B, and then of course this one has to be C because it's the hypotenuse. So we start with our formula. It's always going to be the same formula here. A squared plus B squared equals C squared. A is what we're looking for, so we're just going to leave that as A squared plus B squared, so that's 7 squared. And we know it's 7 because if this is 7, this is 7 because it's a square. Equals 25 squared. So here's our A, that's what we're looking for. B is 7, C is 25. So now we start solving. A squared plus 49 equals, let's see here, 25 squared is 625. So now, just think of this as any old equation. We want to get A by itself, so the first thing we need to do is subtract 49 for both sides. Remember, the opposite or the inverse of adding 49 is subtracting 49. So we're going to do minus 49, minus 49. Make sure that you show me that you're doing that so I can follow your process. And those cancel out. So now I have A squared equals, put it in your calculator, 576. But just like we did a minute ago, we don't want 576, even though that is one of the answer choices. Oh wait, sorry, yes we do. All right, I'm not paying very close attention. If we were looking for A, then we would take the square root of both sides, and the square root of 576, let me put it in my calculator here, would be 24. Okay, so A itself equals 24, and that works because 25 is still the longest side. But since it said the area, we actually do want the 576. So that's going to be our answer. So read very carefully. You always want to know whether you're looking for the area of the square that's created, or are you just looking for the length of the side. Remember, the square has area, the side has length. So that would be 24 centimeters. Here this is 576 centimeters squared since it's area. So now on your own, please work out number 7 and number 8. Number 7 and number 8, and actually, and number 13. Number 7, 8, and 13. Bring those to me for your 3 stamps, and then we will continue with number 17 on the video. Number 17. Which of the following lengths could not be used to create a right triangle? Keyword here is not. Okay, we don't want to get tricked. So this didn't print very well, so this should be 27. That's 36 and 45. B is 21, 28, 34. C, this is 39, 52, and 65. 39, 52, 65. And then D is 14, 48, and 50. Now, all we need to do here is just plug them in and check. So I'm going to first identify the C for each one of these. So here, this is my longest side. This is my longest side, longest, and longest. Okay, so they've actually made it easy for us. They put it last. So all we need to do is check it. Okay, 27 squared plus 36 squared equals 45 squared. Okay, let's look and see. So we're just going to plug it into our calculator. 27 squared is 729 plus 36 squared, 1,296, and then 45 squared is 2,025. And then we just check them. 729 plus 1296 is 2025. So that one works, but it said not a right triangle. So we're going to get rid of that one. So that one is a right triangle. And then we go on to the next one. So 21 squared plus 28 squared should equal 34 squared. And we're going to test. So 21 squared is 441. 28 squared is 784. And then 34 squared is 1,156. And then we check. 441 plus 784 is 1,125. So that one does not work. Okay. So right now we think B might be the answer. Because 441 plus 784 is really 1,125. Let's check C though. We don't want to be lazy and miss something. 39 squared plus 52 squared, 52 squared equals 65 squared. Alright, 39 squared is 1,521. 52 squared is 2,704. Man, aren't you glad we're not doing this by hand? And 65 squared is 4,225. So let's plug them in. 1521 plus 2704 is 4,225. So that one's right. So let's get rid of C. That does make a right triangle. And one more. 14 squared plus 48 squared equals 50 squared. Okay, go ahead and check this one on your own. Just plug them in, work along with me. Okay, so these are the numbers I got. I'm going to add up 196 plus 2,304, and I get 2,500. So that one is a right triangle too. So B is the only one that is not going to make a right triangle. So again, we did some of this yesterday too. All we're doing is testing. We're plugging them in. We're not solving for anything. We're just looking to see if they balance each other in the formula, in the equation. I'd like to do number 18 with you too, but just kind of halfway with you. I'm going to leave these up so you can kind of see what we did. This one says which three lengths could be used to form a right triangle. So we're looking for the one that does make a right triangle. So the first thing I'm going to do is go through and find my longest lengths. Now keep in mind they're being nice to us and putting C last, but they really don't have to do that, so always double check it. So I'm just going to go through and do these silently, and I want you to work them out with me. You can copy, or you can work them out by yourself and then check, but I just want you to have some practice since we've done this a few times now. Okay, for F, I got 1,657. So that means that this is not a right triangle. And remember, here we're looking for the one that is. All right, so let's just keep going. Ooh, that one's way off. 450. That was almost 2,000 off, so let's get rid of that one. All right, and this last one works for me. 2601 plus 4624 does equal 7,225. So that is the one that does make a right triangle. Now, sometimes you may have a right triangle where A and B are the same length. That can happen, but just not in this case. Okay, so I'm going to ask you now to do number 19 on your own. So we've done 2 of these together today, and then a couple yesterday, so you should be a pro at this type of problem by now. Workout number 19, show your work, then come bring me your paper for your stamp, and we'll move on. Okay, number 22 says, Brad is standing on a hill, which places him at the same height as a nearby flagpole. If the flagpole is 15 feet high, and he is 20 feet from the top of the pole, how far is it to the bottom of the hill? So, this sounds like gibberish, so that's why it's good that we have a picture. So it's telling us that the pole is 15 feet. It's telling us that he's 20 feet from the top of the hill. I'm sorry, from the top of the flagpole. So this is Brad over here. Hi, Brad. Okay. He's 20 feet away. And so we just want to know how far it is to the bottom of the hill. So that's our C. And of course, here's our right angle. And so now we have a right triangle, and we can just plug these numbers into our formula. So let's look here. We're going to start off with a squared plus b squared equals c squared. So always start with your formula. We will always want to write that first. And then we can plug in what we know. Well, we know a is 15, so 15 squared. And then we know that b is 20, 20 squared. And we don't know what c is, so we're just going to leave that. C squared. Okay, and then we can put these numbers in our calculator. 15 squared is 225. 20 squared is 400. And that equals c squared. So we're just bringing this down because we're not doing anything with it yet. And then we have, we just add these together. That's 625 equals c squared. Again, we're going to be taking a lot of square roots. Let's take the square root of both sides. Because it's not asking us for this square that's made over here. It's not asking us for the area of that. It's asking us for the length of c. So we don't want to keep it in squared form. So the square root and the square cancel out. I have c left. And we can put in our calculator the square root of 625 is 25. 25 feet. So let's put it over here. That makes sense. It's our longest side, and that is our biggest number. We did answer the right question. It said, how far is it to the bottom of the hill? And so we just plugged in our information and solved for what we didn't know. Number 24 is very similar to this one. When you look at 24, don't get mixed up with this. I'm going to go ahead and help you out with that just a little bit. If this is 1 foot, and of course this isn't part of a triangle, this would be our triangle right here, then you know that this is 8 feet, but this is no longer 6 feet. What would it be? It would be 5 feet. So the legs of our triangle are 5 and 8, not 6 and 8. So anyway, I'm going to leave you to this. When you're finished, bring me your paper for a stamp, and then we will look at number 26 together. Number 26. First of all, this is a hexagon. Okay, it's a regular hexagon because it has 6 sides and all 6 sides are the same. The diagonals of a regular hexagon form 6 equilateral triangles. So we have 1, 2, 3, 4, 5, 6 equilateral triangles. If each side of the regular hexagon has a measure of 2 units, so we're shown here that each side is 2 units, use the Pythagorean theorem to determine the height of a triangle in the hexagon. Round your answer to the nearest tenth. Okay. So first of all, let's make sure that we can see our numbers. We know that this is 2, And we know that this is 2. And let's kind of pull out the triangle that we're looking at, because we're not looking at the whole hexagon. All we care about is one of these little triangles. And we want to know the height of the triangle, which is this right here. Okay, this is what we're looking for. So here's our triangle. That's the hypotenuse. This is one leg, so we want to be really careful. We're not going to use the whole base of the triangle, because then it would be an equilateral triangle. And it would be acute. We want just this right here. So there's our triangle. Which means that if I go ahead and draw that over here, that's my right angle. We know that the hypotenuse is 2, but if the whole base here is 2, then that means that half of the base, this part right here, is only 1. And then this is what we're looking for, and that's not the hypotenuse, so let's just call it A. So we are still solving the same formula. A squared plus B squared equals C squared. We don't know A. B is 1. And C is 2. So A squared plus 1 squared equals 2 squared. Okay, let's bring down A squared since we're not really touching that yet. 1 squared, 1 times 1 is 1. And we all know that 2 times 2 is 4. So we have A squared plus 1 equals 4. Let's get A squared by itself. So we have to do the opposite of adding 1, which is to subtract 1 from both sides. These cancel out. And I have A squared equals 3. But again, we are not being asked for A squared. We want to find A, the length of this side, or the height of that triangle. So we're going to take the square root of A squared and take the square root of 3. That way we can cancel out and get A by itself. And this one, 3 is not a perfect square, so we're going to have to put that in our calculator. It said round to the nearest tenth. So the square root of 3 equals 1.73205 ... Rounding to the nearest tenth, that would be right here. So we look at the next number. The 3 tells us to round down. So it's going to be 1.7. A equals 1.7. And this is units. They didn't tell us anything different. So the height is 1.7 units. That does make sense because 1 and 1.7 are both shorter than our hypotenuse of 2. So it works. Now you're going to do number 29 on your own. You have part A and part B. So part A is just labeling the drawing, and then part B is working it out. So if you'd like to bring me your paper after you finished A to make sure you have it set up right, and I can stamp A, and then you can work on B. That might save you a little bit of time. And then when you're finished with this one and you have all of your stamps, we're going to be turning this paper in.